video, we will study pulse amplitude modulation. Basically, pulse amplitude modulation is a process in which the amplitude of the pulse is varied in accordance with the instantaneous amplitude of massive signal at sampling rate. The wait time position of the pulse is kept over time. PAM is a pulse modulation system in which the signal is sampled at regular intervals and each sample is made proportional to the amplitude of the signal at the instant of sampling. Pulses are sent by either via a cable or else are used to modulate a carrier. Basically, PAM is of two types: double polarity PAM, which is self-explanatory, and single polarity PAM, in which a fixed DC level is added to the signal to ensure that the pulses are always positive. The ability to use constant amplitude pulses is a major advantage of pulse modulation, and since PAM does not utilize constant amplitude pulses, it is infrequently used. This is block diagram for generation of pulse amplitude modulation. The massive signal and pulses at sampling frequency are fed to the input of AND gate. The output from AND gate is fed to the pulse shaping network, and after that we frequency modulate signal and ultimately we get pulse amplitude modulated FM output. This is our massive signal. This is carrier signal. When the massive signal is pulse amplitude modulated with the help of this carrier signal, we get a PAM modulated wave like this. So we'll perform this experiment on the kit. In this kit, we have a pulse amplitude modulation system. It requires two input signal, that is a signal from signal generator, that is massive signal, and a signal known as carrier signal from ramp generator. In this kit, we have a signal generator. We can select various types of signal types from this selector switch. We can have sine wave, we can have square wave, we can have triangular wave. Arbitrary signals can be also obtained from this signal generator. The signal frequency can be varied with the help of this selector switch. We can have 500 Hz signal, we can have 1 kHz, we can have 2 kHz, 3 kHz signal frequencies. Similarly, the sampling frequency can be varied with the help of this selector switch, having 1.25 kHz, 2.50 kHz, 5 kHz, 9.8 kHz, 19.53 kHz, 39.06 kHz and 78.13 kHz. So in pulse amplitude modulator, we have three kind of sampling: natural sampling, flat top sampling, and sample and hold technique. So with the help of this kit, we can have output as natural sampled signal, flat top sampled signal, and signal after sample and hold operation. So let us measure the input and output with the help of digital storage oscilloscope. We can put this switch, signal generator switch, at internal side, and let us select the signal type as sine wave for massive signal, and the signal frequency is selected as 2 kHz. Sampling frequency is set by this push button switch as 39.06 kHz. Now let us measure the input and output The input is measured at point number 2 of the pulse amplitude modulator, and output is measured at this 4 number pin of the natural sample output. And we connect common ground at this terminal. In this way we have waveform like this. This is our message signal and this is our pulse amplitude modulated wave. You can observe that in natural sampling we are getting amplitude modulated wave, which is sampled version of a message signal. In this way we have obtained natural sampled signal. In order to observe response of flat top sampling, we will connect the probe of CRO at the output of flat top sampling point and will observe the output like this. So this is the output of the PAM modulator using flat top sampling. You can observe that the top of the signal is flattened. Again, you can observe the response of sample and hold circuit by connecting the knob at the output of sample and hold. This way you can observe the output of PAM circuit like this. So this is the sampled and hold PAM modulated wave. Thank you very much.